Hey, welcome to the Explainer. Today, we're going to talk about Redis. It's the secret ingredient that makes pretty much every high-performance app you use feel so fast.
Look, we've gone through hours and hours of YouTube tutorials from the top system design experts, so you don't have to. We're going to cover what Redis is, why it's so darn fast, and how it's used to build these incredibly massive, scalable systems.
All right, so here's the game plan. First, we need to understand the problem Redis solves. Then, we'll get into what it actually is. After that, we'll see how it scales up. And finally, we'll look at some real-world examples.
So before we can even talk about what Redis is, we got to understand the problem it was built to solve. And it all comes down to a massive bottleneck in basically all of computing, the huge difference in speed between your computer's memory and its storage drive.
And when I say massive, I am not kidding. Check this out. Getting data from a disk where your typical database lives takes milliseconds. But from memory or RAM, we're talking microseconds. That is literally over 1,000 times faster. It's not even in the same ballpark.
So you can see the issue here, right? If your app has to talk to that slow database every single time a user does something, it's going to feel like it's crawling through mud. This is exactly why we need something called a cache. It's like a super fast pit stop for data, sitting right in memory, protecting that main database from getting hammered with the same requests over and over.
Okay, so enter Redis. This is where things get really cool, because Redis doesn't just solve this caching problem, it does so much more. People call it the Swiss Army knife of data stores, and for a really good reason.
Now this definition is everything. In memory, that's the secret sauce for its speed. Single-threaded. Now that might sound like a bad thing, but it's actually genius. It simplifies everything by just doing one thing at a time, which means no messy conflicts. But the real magic is in that last part, data structure server.
Yeah, exactly. This is the key insight. Redis isn't just some dumb box where you store a key and a value. No, it's way smarter. It lets you use all those fancy data structures you learned about in school, like lists, sets, and hashes, but on a huge, distributed network. It's a total game changer.
And you know what's awesome? It's ridiculously easy to use. The commands just make sense, you set a value, you get it back. You can increment a number without worrying about anything else happening at the same time. And you can tell a key to just disappear after a certain time with expire. That simplicity is a huge part of why everyone loves it.
Okay, so Redis is super fast and easy on one computer. Great. But what happens when you're running an app with millions of users? How in the world does a single-threaded server keep up with that kind of crazy traffic?
Right? This is the question every engineer has to answer. How do you scale up to handle more load? And how do you make sure that if one server dies, your whole app doesn't go down with it?
Well, Redis has a two-pronged attack for this. To handle more people reading data and to make sure your system stays online, use replication. That's just making copies of your data. But to handle more people writing data, you use sharding. And that means splitting your data up across a bunch of different primary machines.
And the way it splits up that data is actually pretty slick. Basically, every piece of data, every key, gets put through a function that assigns it to one of about 16,000 slots. Then, the different computers in your cluster just divide up those slots. So when your app needs some data, it knows exactly which machine to ask. Super efficient.
All right, enough with the theory. Let's talk about how this stuff is actually used in the real world. How do developers take all these features and build the fast apps we use every day?
So number one, and this probably won't surprise you, is caching. This is the bread and butter of Redis. It's the most direct solution to that speed problem we talked about at the very beginning.
And the way it's usually done is with a pattern called cache aside. It's super logical. Your app asks Redis for some data. If Redis has it, boom, a cache hit. You get it back instantly. If it doesn't have it, that's a cache miss. No problem. The app just goes to the slow main database, grabs the data, puts a copy in Redis for next time, and then gives it to you.
Okay, use case number 2, rate limiting. You've definitely seen this. It's what stops you from hitting refresh 1,000 times a second and crashing a website. It's absolutely crucial for protecting your services. And again, Redis makes this so elegant. You just create a special key for each user within a specific time window, say 1 minute. Every time they make a request, you just run that atomic in-car command. If that counter goes above your limit, say 100 requests, you just tell them to slow down. And that expire command, it automatically cleans up the counter when the minute is over. It's beautiful, simple, and works across your entire system.
But wait, there's more. Seriously, the list just goes on. Because of those powerful data structures, you can build all sorts of cool stuff. Real-time leaderboards for games? Use sorted sets. Finding all the coffee shops near you? Geospatial indexes. Running background jobs, building chat rooms, you name it. It is just so versatile.
So when you zoom out, that's the takeaway, right? Redis is this amazing mix of being simple, incredibly versatile, and just blazing fast. It's truly one of the fundamental building blocks for any modern high-performance system.
And it kind of makes you step back and think. Reid proved that a really simple model can solve incredibly complex problems. So it leaves you with this question. In a world that's always getting more complicated, what's the next big system that we could simplify? Something to think about. Thanks for watching.